Today we're going to make this object space tiling shader for HDRP, but the same principle should work in URP as well. It honestly blows my mind that something as fundamental as an auto tiling shader isn't built into the Unity rendering pipelines. But here we are, so let's get stuck into it. To head off any Captain Obvious comments about triplanar blah blah blah, we'll just take a brief look at the difference between screen space, world space, and object space tiling, and why triplanar mapping won't get you out of trouble. Here we have the standard HDRP material, obviously no tiling. The front-facing UV on an object is the last face you want upside down. But the guys at Unity decided it was going to be the only face that's upside down, so whatever, f*** you. This is a screen space material. No matter which angle you view it from, it will always be the same orientation, because it's projected in a single plane, which means rotation, depth, and stuff like that doesn't exist. Shadows are still cast onto the object though, and staring at a screen space material for too long tends to make me sick. So moving on. Triplanar, as the name suggests, is a planar projection in each plane of X, Y, and Z. At the end of the day, however, it's still just planar projection, so when an object rotates off one axis into another, you have two options. Rough cut to the next plane when the object rotates off the current one, or blend between the two planes and hopefully nobody notices. Unity went with the latter, which is why you see this montation here. Again, we're essentially dealing with a planar projection, so the texture doesn't give a fluffy duck about the scale or the rotation of the object it's applied to. Thus, if you switch to object space mapping, you lose the advantage of triplanar mapping as it becomes stretched or squashed depending on the object scale in each axis. No combination of triplanar object space or world space mapping will solve this problem due to the aforementioned fluffy duck the material doesn't give. This shader essentially tiles the texture in the X, Y, and Z planar perspectives or something to get around that problem, so let's get stuck into it. To begin, create a subgraph and a lit shadergraph. Call them something complicated to impress your friends. Then whilst we're here, make a material from the main graph and apply it to the object in the scene. Preferably a cube so we can test each plane, or face, or whatever. Open the subgraph, create a normal vector node and set the space to object. We're going to need 3 custom function nodes to limit our spaghetti intake, and whilst we're at the outbox end of the graph, we might as well hook up a tiling and offset node and create a vector2 offset property for the offset. Next, go to the first custom function node and admire how fucking tiny the text is. Set the type to string and name it something like normal vector processing. Set a vector3 input, and in the body we'll need a float3 absolute of the vector to prevent negative numbers. Basically, this function compares each vector and sets them to either 1 or 0 to create a mask. There are several ways you could go about a normal vector comparison, but I went with max because I want my graph to have personality. Max takes the highest value of X, Y, or Z, whilst step flattens them out depending on the result, I think. Set a vector3 output called mask and hook up the normal vector. If you have done it right, you should see maxed values in each RGB channel that correspond to the X, Y, and Z axes, forming the mask. The second custom function node handles the scaling of the texture on each face. Set the type to string, name it UV scaling processing or whatever, and set a vector2 UV scale input to control the size of the tiling. You might be able to multiply the UV output just before the tiling and offset node instead of scaling it here, so if that works let me know in the comments. But for now, create the vector2 UV scale property. Set a default value of 1, or don't because it will have an input anyway, drag it in and hook it up. Set a vector3 object scale input, create a vector3 object scale property and hook that up as well. This custom function node will output 3 vector2s corresponding to the X, Y front and back, Y, Z sides, and X, Z top and bottom triplanar axes. I always get the Y, Z and X, Z mixed up, so you'll probably see me fuck it up here. The UV math is thankfully pretty easy, and we can calculate them inline in the output declarations. All we really need to do is divide the object scale by the UV tiling scale in the X, Y, Z, X, Z planes. Once you have spelled everything correctly, move on to the third custom function node. This one's going to funnel the correct axis UV through to the tiling and offset node. It's a bit more complicated than that since it's a fragment shader, but who cares? Set it to a string, name it axis processing, and get ready to set a lot of inputs. You'll need a vector3 mask and 3 vector2 UVXZ fucking inputs. And go ahead and connect the normal vector mask and UVs up. It's worth noting that there are at least 276 different ways you could approach the vector split, but they fall into 2 main categories, branching and non-branching. Theoretically, non-branching should be faster because at this point we haven't sampled any textures and are just operating on a bunch of vector 2s. However, my suggestion is to complain to Unity that you want them to make a proper tiling shader graph and save everyone the trouble of watching a hack tutorial like this one. We're going to go with branching, so essentially all we have to do is check with your mum about which of the normal vectors have a value greater than 0 and set the corresponding UV to the UV out. I royally fucked this up, so just copy this into the body and then connect the UV out to the tiling thingy on the tiling and offset node. And with that, the subgraph is done. Clean things up a bit, save it and head to the main shader graph. With the subgraph doing all the heavy lifting, the main graph is super easy. Create a Vector2 UV scale property with a default value of 1 in the X and Y fields, a Vector2 UV property, and Texture2D properties along with their float strength multipliers where relevant for all of the different texture maps you want on your material. Subgraphs become nodes in the main graph, so create your object space vector subgraph node and an object node taking the scale out to the object scale in on the subgraph. Drag the UV scale and offset properties in and hook them up as well. From here it's just a matter of creating a bunch of sample texture 2D nodes, feeding the UV from the subgraph in and setting up the relevant strength multipliers. Don't forget to set your normal map sample texture normal to normal. Once your graph looks something like this, in the graph settings we just need to enable alpha clipping in case you want to tile something like a fence or whatever, double-sided mode, clear coat if you're using it, and depth offset if you don't care about performance. Save it, drag the main graph material onto your cube, set at least a base map and normal map, and bam, the work is done. At this point I'd like to thank my patrons, and if you would like more free shader tutorials, consider sending me money. Thanks for watching.